Today, we will talk about the least squares method that is used to determine the line of best fit for a set of data, providing a visual demonstration of the relationship between the data points. The least squares method is a mathematical regression analysis used to determine the line of best fit for a set of data, providing a visual demonstration of the relationship between the data points. Each point of data represents the relationship between a known independent variable and an unknown dependent variable. This method is commonly used by statisticians and traders who want to identify trading opportunities and trends. The least squares method is a form of regression analysis that provides the overall rationale for the placement of the line of best fit among the data points being studied. It begins with a set of data points using two variables, which are plotted on a graph along the x and y axis. Traders and analysts can use this as a tool to pinpoint bullish and bearish trends in the market along with potential trading opportunities. The most common application of this method is sometimes referred to as linear or ordinary, and it aims to create a straight line that minimizes the sum of squares of the errors generated by the results of the associated equations, such as the squared residuals resulting from differences in the observed value and the value anticipated based on that model. An analyst may use the least squares method to generate a line of best fit that explains the potential relationship between independent and dependent variables. The line of best fit determined from the least squares method has an equation that highlights the relationship between the data points. One of the main benefits of using this method is that it is easy to apply and understand. That's because it only uses two variables while highlighting the best relationship between them. Investors and analysts can use the least square method by analyzing past performance and making predictions about future trends in the economy and stock markets. As such, it can be used as a decision-making tool. The primary disadvantage of the least square method lies in the data used. It can only highlight the relationship between two variables. As such, it doesn't take any others into account. And if there are any outliers, the results become skewed. Another problem with this method is that the data must be evenly distributed. If this isn't the case, the results may not be reliable. Here's a hypothetical example to show how the least square method works. Let's assume that an analyst wishes to test the relationship between a company's stock returns and the returns of the index for which the stock is a component. In this example, the analyst seeks to test the dependence of the stock returns on the index returns. To achieve this, all of the returns are plotted on a chart. The index returns are then designated as the independent variable, and the stock returns are the dependent variable. The line of best fit provides the analyst with coefficients explaining the level of dependence. The least squares method is used in a wide variety of fields, including finance and investing. For financial analysts, the method can help to quantify the relationship between two or more variables, such as a stock's share price and its. Here are 5 key takeaways. 1. The least squares method is a statistical procedure to find the best fit for a set of data points. 2. The method works by minimizing the sum of the offsets or residuals of points from the plotted curve. 3. Least squares regression is used to predict the behavior of dependent variables. 4. The least squares method provides the overall rationale for the placement of the line of best fit among the data points being studied. 5. Traders and analysts can use the least squares method to identify trading opportunities and economic or financial trends. Hope this would help. Thanks for watching.